Welcome to Study Loop.
What we have here are different proportional situations. We have, maybe you call it the side-splitting theorem, but for instance, x minus 2 to x minus 5 is in proportion with, in the same order, 2x plus 1 to x minus 1. And so then to solve this, we'll cross multiply. X minus 2 times x minus 1 equals 2x plus 1 times x minus 5. Multiply the left-hand side by what we call FOILing. You get x squared minus x minus 2x is minus 3x plus 2. And then FOIL the second side. We get 2x squared minus 10x plus x would be minus 9x, and then minus 5. Now we could subtract x squared to both sides. We could add 3x to both sides. Negative 9x plus 3x is minus 6x, and then we can subtract 2 to both sides. And finally, this is a quadratic that can be factored, or multiplies a negative 7 and adds to negative 6. That would be x minus 7 and x plus 1, which by the zero factor theorem would mean x is equal to 7 or x is equal to negative 1. But really, the negative 1 won't make sense, because if you check your answers, like, we're not going to want negative side length, so I would not include that one. I would just say 7. When we have an angle that's bisected in a triangle, then we have proportional parts. Something like 10x minus 2 to 8x, same as 7x to 5x plus 3. You got to go in the same order. Cross multiply, we'll have 10x minus 2 times 5x plus 3 equals 7x times 8x. Distribute, we've got 50x squared plus 30x minus 10x would be plus 20x minus 6 equals 7 times 8 is 56x squared. This is going to be a quadratic again. Let's get a positive x squared by subtracting everything so that we have a 0 on the left-hand side. So when we subtract 50x squared, we'll have 6x squared, then minus 20x, and then plus 6. Again, we're moving everything to the right-hand side. Okay, then everything is even, so we can bring these down by a factor of 2 to make it a little bit easier on ourselves. And then this is factorable as well. What multiplies to 9 and adds to negative 10. That would be negative 9 and negative 1. And now we can do grouping. And with the first group, we can factor out a 3x, left with x minus 3. In the second group, we can factor out a negative 1, left with x minus 3. And now we have the common x minus 3, and then what we took out, 3x minus 1. Now by the zero factor theorem, that would mean x minus 3 is equal to 0, and 3x minus 1 is equal to 0. Or x is equal to 3, or x is equal to 1/3. Now check your answers again. Would 1/3 work? I think it might actually. So both of these could be solutions here. Let me check that out. Yeah, I think both are solutions. Last one, it's the side splitting theorem again. You could say like 3x plus 1. I'm going to do this way down below. You could say 3x plus 1 to 4x plus 4 along the left-hand side, in proportion with go along the right-hand side in the same direction, 2x plus 2 to 18. Cross multiply, we got 18 times 3x plus 1 and 2x plus 2 times 4x plus 4. Distribute the 18 times 3 is 54x plus 18 equals, we've got 8x squared plus 8x plus 8x is plus 16x plus 8. Let's again get this all on the right hand side. We'll have 8x squared. 16 minus 54 is negative 38x, and then subtract 18, we'll have minus 10. They're all divisible by 2, so we can reduce this to 4x squared minus 19x minus 5. We'll multiply as the negative 20 as to negative 19. That would be a negative 20 and a positive 1. Factor by grouping. From the first group, we can take out a 4x, left with x minus 5. In the second group, we can take out a 1, left with x minus 5. And so we have one factor of 4x plus 1 and the common factor of x minus 5. By the zero factor theorem, set these equal to 0. X could be subtract 1 divided by 4, negative 1/4, or 5. Negative 1/4 would work. And so I think you'll have two solutions again. I hope you found this helpful. Good luck.